Here we're going to talk about opening Cadence like you haven't used it before. This is assuming that you've already installed it and you have all the file paths correct. I'm not going to go through that because this is a remote computer that I'm using, and those are liable to change depending on what the school and Cadence want to do. But assuming you have everything installed, then this is how you start the process. So the program is called Capture CIS, and you just type in capture in the search bar and then open it. You're going to do PCB Design CIS. And here's the splash screen. You're going to go to File, New, Project, and then just name your project what you want it to. Presentation for class. And this is my new project. Up here, if it doesn't automatically display your schematic, you'll just go up to Design Resource, open up the presentation for class or your name.dsn, schematic, and then page 1. And now you're on the page to begin placing parts. Here we're going to talk about how to begin placing parts and where they are located. Up here in the top right is a place part icon, or you can use the hotkey P. From here, these are already populated, so I'm going to go ahead and get rid of these just to show you exactly what you need to do. So this is what you'll see. Design Cache has stuff from your design and has you make edits. It's going to be there. So that should automatically be populated, and if it's not, it will once you start adding things to your schematic. Down here is the Add Library button. This is the file path that are on the school computers. It might change depending on how Cadence does it, but if you end up needing it, here is where it is. Under here are a number of libraries. There's going to be a few that you're going to want to use often, and the big ones are Connector and Discrete. Those are the two main ones that you're going to use, and I would add them pretty much every time. There's a couple other ones we'll go through real quick. These, I believe, were added by other students. But down here, electromechanical is going to be things like motors and speakers, that type of thing. You'll see microcontrollers and microprocessor. You're usually not going to use those. If it has it, then awesome, but a lot of times you're not going to end up seeing your part in here. And I'll show you after this how to search for a part as well. So down here, you'll see op amps. Power source, I think, was added by a student. You'll see a lot of these have the same dates on them, and then some of these other ones students added. Shift register is another big one, and transistor. But for what we're doing right now, we're just going to use these two libraries over here. Here we are going to make a very simple schematic. For this one, it's just going to be a connector with a resistor and an LED on here. So the connectors that you're going to end up using for this is just going to be here we are going to talk about how to make a schematic. We're going to make something very simple, just a connector for the off board, a resistor, an LED, and a jumper. So in the connector one, we're going to add the header, and then header, whatever number you want for however many pins that are going off the board, and we're just going to use 2. So you see the part here, and you can either do place part up here or press enter when it's selected, and then this gives a view of the schematic. So we're going to want to place all our parts first. So we're going to do the header, we're going to do a jumper, and then if you want to do multiple jumpers together, you can. This is just a different visualization of the jumper, so we're just going to go ahead and use this one. If you're not sure what a jumper is, I would just do a quick Google image search of PCB jumper, and that'll show you exactly what that is. But it allows you to disconnect different components on your board, which would be good if you soldered them down and you want to isolate them. So these are the connectors. Discrete, which we explained why we want these 2 in another video, but discrete has your components that you really need, like resistors, LEDs, capacitors, that type of thing. So we're going to place a resistor, and if you need to rotate your part, just press the R key, and then LED. So now that we've placed our parts, we can drag them around wherever we want to put them. If we want to make it better, do R, drag it around however we want. So this is going to represent basically power coming in, and then we need to connect the wires and then back around. So in order to do this, over here you're going to see underneath place part is place wire, and W is the hotkey for that. So we're going to do this. And now we have a schematic. Very simple, and this could be exported to a PCB technically if we wanted to just do this. One of the things to watch out for that some people sometimes do is they will place a line. A line is not an electrical connection, and to show that, we're just going to delete this and then place this line. And it looks like it might work, but what you see is that there is this square at the end of the component. When the square is open, it means that there is no electrical connection there, and you're going to get errors when you try to export this. So delete lines and place wire. And that's our schematic. Here we're going to talk about the netlist alias and how that all works. There's a couple different ways to do this, and basically what you're going to end up doing is separate your components into the functionality. So over here we're going to say that these are the power components, and over here we're going to say that this is the functional component of the LED and resistor, and these parts go together because you always need an LED with a resistor. We're going to leave this for now, and we're going to rotate this. Stop. Here we're going to talk a little bit about netlist alias and then how to lay out your schematic. So one of the things you want to look at doing is placing components by functional type. So over here we have a power part of the board, and we have the LED part of the board. So power and then what you want to function. So one of the things you can do is begin to split this up, and this is just the line tool from down over here, and then you can do place and either text or hotkey T, and we're just going to do power subsystem. We're going to place it over here. Down here, there's also the place text if you click on the little arrow, and then we're just going to do LED subsystem. Obviously, in your projects, they're going to be more complex, so whatever type of subsystem, your communication or shift register or whatever part, you just name that however you want. And then right click and edit properties to change the size. Font change. We're just going to make these 14 for now. So now we have the parts split up as they are by function. One of the things you can tell is that these two are not connected at all. They're completely separate on the board. And in order for Cadence and the PCB editor to understand what is happening, we have to make sure that these are connected. Instead of running the wires all the way through here, and when you get into more complex designs where you're going to have 30 wires coming off of a microcontroller, we use what's called a netlist alias. Over here, you'll see the wire with the N in it, or hotkey N. And what we're going to do is create a name for this alias. And for this one, we're just going to do, let's see, 3 volt. So we're going to say 3V. I'm going to place it on this line. You can see that I can't place it anywhere just random. It has to be on a line. Normally, you're not going to want to do that with 3 volt. What you're going to end up doing is go to place and then do a power, and you have your VCC. So we're going to do capsim, and that'll work too for your netlist. But I want to show this netlist tool over here. And then the same thing for the ground. So we're going to do ground. I would not advise using this one. We've had some errors with it, but just use the ground capsim. And then place that there. And normally you're not going to want to do that like that, so you can just drag it down. And you'll see it's connected because that square ends up disappearing. So because we use the VCC, we can go ahead and get rid of these. Sometimes you can use 3 volt, and sometimes you'll need to when you're running multiple power rails. So sometimes you're going to need a 5 volt rail and then a 3.3 volt rail. And if you need that, then you can use the 5V or 3V from the net alias over here. Now here, the computer, the program, understands that these are connected. So everything that has a VCC is connected to another VCC. So if we were to place another component, which we're going to do real quick, so LED, and then resistor, and then we'll just run those wires, W, and then again place that power. And you want to make sure you use the same ones again, because if you use one of the other ones on here, it's not going to understand that it's the same one. So use the same one again, do that, and then place the ground. Again, use the same part. So now it understands that this ground is connected to this ground, is connected to that ground. It's the same thing as running a wire basically from here to there. Here we're going to talk about finding some of the common parts that are inside of Cadence. So you'll see a lot of ICs that you'll just see a lot. Down here is a search for part, and inside this path is that path that I showed you in another video where all of your libraries are located. Same one that was right here. if you're looking for a part, and in this case we're going to use a shift register, so the 74HC595, which is the most common shift register. We search for that, we find that it is in the shift register library, which makes sense. We can select this part and we can add the library down here instead. So now this is here and it's automatically directed us to that shift register. This makes it a lot easier if you think that your part is in there, then you can end up finding it and adding that library very easily. So we're going to go ahead and place this part real quick. And then these are different outputs. With this shift register, you don't have to use every output, but we're just going to use the first 4. And in reality, you would end up connecting up the SDI, the R clock, all of this to another, to your microprocessor. But for this example, we're going to just say that these aren't connected, and we're going to use this part over here, which is the no connect, or hotkey X. If you're not connecting things to it, then you need to put this X on every pin that you're not using. Again, in reality, this shift register wouldn't work if we were not connecting all these pins because of how it functions. But to understand the connections, and if we were to try to put this on the board, then all of the ones that aren't used need to be X like that. And because this is all part of the same subsystem, we can put this together. If you wanted, for simplicity, to make this a different thing, we use that netlist alias like we were talking about earlier and put this in its own subsystem. And if we're going to do this, we can go ahead and rename this to shift register subsystem.